floor is yours.
Thank you, Uroš. So before I start, thank you, Uroš, and your team, obviously, and your consortium for inviting me over here. It's been fun so far, and there's been a lot of interesting talks, so I've already learned a lot, and I think when you will see my talk, which is a bit more sports science directed, I think, I mean, we were kind of talking about it already yesterday over dinner. There's quite some possibilities to take it one step further, and I think those possibilities lie mainly in what you and what we are doing and what we have been presenting here until now. So this is just a picture of the university. I thought I'll put it in. It's I think it's a nice picture. It's from quite some years ago, but still, we are evolving. There's new buildings by now, but voila, there we go. So different faculties. Our faculty is the Physical Education Physiotherapy faculty, and we, well, we're not that big of a university, but we're also not small. I think we have like 20,000 students in total at the VUB. Within our faculty, we are at about 900 students, and we have quite some staff as well, and we have 36 professors for only 800 students. That's actually because, well, in Belgium the system works a bit different, so you can be 10% of a professor. You don't have to be 100% of a professor, so you can be just a little bit of professor. So that makes that we have quite a lot of heads in terms of professorships, but it's not all full-time stuff. Okay, so our research group is the Human Physiology and Sports Physiotherapy Research Group. We have one of those nice new buildings that I think we're in that building now for 5 years or so. And so we have this nice climate chamber, and you probably know this guy from somewhere. So this is a very nice room. We can go from 5 to 50 degrees Celsius. We can adapt humidity, and we can adapt altitude as well. So we can go up to 6,000 meters in there. So that's where we do most of our experimental trials at the time. If we look at our group, and if we look at the main research goals we have, we are working on exercise and the brain in health and disease. So everything's coupled back to that specific motto, let's say, and within that we obviously have different research lines going from, well, I'll start at the bottom just to do it a different way. So there's disease and the brain, where we look at, for example, at the overtraining syndrome, meaning people who train too much, added with some psychological issues and so on, who just can't perform anymore. So who feel that they are performing worse every time, have the reflex to start training more because probably they're not training well, while in the end that's not the idea, of course. And what you get is sometimes they never recover to their previous level. Injury prevention, sports injuries is a research line that's really picking up at the moment. Florian, I think, there you are. Florian, that's something you will be very interested in. We are doing similar things as the things you are doing. And then, well, this is going to be your talk for Saturday. So Kevin will be talking about the human robotics things we are doing in the lab, which is also a very extensive research line by now. So that's for Saturday. We have things on nutrition and the brain, physical activity and the brain, and then also health and the brain, and that's where I will be going into today as well. So we look at physical and cognitive exercises or cognitive fatigue. And there's also, well, one PhD trajectory at the moment where we look at brain age. So in using fMRI, we determine the biological brain age, and we compare it with the actual age of our subjects. But that's other things, of course. So for today, I will be talking about physical and, my time just started. Wonderful. So that was the introduction, that doesn't count. So now we will be, I will be talking about physical and mental fatigue and how they are linked together. So if there would be any issues at a certain moment, just send me an email. I'll be happy to reply. Okay, so just to get started, we'll be talking about fatigue. We are talking in sports science, so I just want to make sure that we're all talking about the same thing, and because fatigue has a lot of definitions and you can interpret fatigue in many different ways. And this nice word cloud here actually proves that, so that everybody looks at it in a different way. I've just highlighted a couple of words that are in that word cloud. So you have tiredness. This is the feeling we usually associate with fatigue. And then here you see a couple of things. Bored, for example, is something that can lead to feelings of fatigue, but I kind of highlighted this one more for the business part and the career part, because when we're like for us in academics, we work quite some hours and we are in front of our computers for a long time, and that can also lead to fatigue. Stress is obviously coupled to that, but I didn't highlight this one because of the stress, but there's this very small written word here, resting, which is obviously the most important cure for fatigue. There's a lot of things in here as well. I highlighted it. Well, exercise, that's what I'll be talking about later on, and then also the body, let's see, the periphery. And finally, our head, our brain, that is involved in fatigue as well. So, my talk is kind of divided in two parts. For the first part, we will be talking about the physical component of fatigue, so meaning the fatigue that is induced by performing exercise. And then in the second part, it will be more related to the mental aspects of fatigue, meaning the fatigue that is induced by doing a prolonged cognitive task. So, physical fatigue, how do we define that? So, exercise-induced fatigue, again, has a lot of definitions. I've selected a few. So, it's the failure to maintain the required force. So, the fact that you're unable to maintain a certain level of force, and the inability to continue working at a given exercise intensity. If we relate it, for example, to the Tour de France, well, we could say that it's the inability for you to respond to your adversary doing an acceleration, for example. Or in a time trial, when you're doing a time trial, which is maybe even a better example, you will select a certain pace and you will try to keep up that pace until the end. But what often happens is that you will be slowing down towards that end point because you can't keep up, or you can't keep on producing the same power output that you are that you would like. So, what was quite clear, and what has been clear for a very long time now, is that exercise is, or that fatigue during exercise has some peripheral aspects. I think there's the accumulation of metabolites and so on. There's a depletion of energy sources, all those things that lead to fatigue. So that's been known for quite a while. But what is interesting is that over the last 30 years by now, 40 years probably, there's also much more interest and much more knowledge about the central component of fatigue. So meaning the fact that our central nervous system, our brain, is also involved in getting fatigued. And one of the important moments there was, I think in the late 1980s, Newsholm and his colleagues published a paper in which they put forward the central fatigue hypothesis. And the central fatigue hypothesis is a hypothesis that states that changes in brain neurochemistry will induce feelings of fatigue. In first instance, that was related to serotonin. So the brain serotonin. And later on, the hypothesis itself was a bit adapted because also dopamine was involved. And as we will see later on, I'll show you a couple of the studies that we've performed in implementing these different neurotransmitter systems. So central fatigue hypothesis states if the concentration of serotonin in your brain goes up, you will get feelings of fatigue. Just to show that a bit further, how that works exactly, or how that's hypothesized exactly, obviously here's a overly simple representation, obviously, our brain on the top side and then our periphery on the bottom side. And the important things here, so we have serotonin, we have tryptophan. Tryptophan is converted into serotonin in the brain. Serotonin doesn't cross the blood-brain barrier, it's tryptophan that does that. It's tryptophan that crosses the blood-brain barrier and then is transformed into serotonin. So this is our blood-brain barrier here. And what we see in a normal situation is that most of our tryptophan is bound to albumin. There's a bit of free tryptophan which is ready to go over the blood-brain barrier, but that has to compete with the branched-chain amino acids for the transporter. So, and in normal situations, there's much more BCAAs than there is tryptophan, meaning that there's not too much tryptophan crossing the blood-brain barrier. Okay, so that's the normal situation. What is happening during exercise? A couple of things: more free fatty acids, and they have a higher affinity for albumin than does tryptophan, which causes tryptophan to lose its place on albumin, so there will be more tryptophan available. We are using our branched-chain amino acids as well, so the ratio between free tryptophan and the BCAAs changes drastically. What causes that more tryptophan will cross the blood-brain barrier. More tryptophan in our brain will mean that there's more serotonin as well. Okay, so that's the general idea behind it. That's how we get into that feeling of fatigue. And that has been a starting point for quite some studies, new research lines, let's say, in which the scientists were trying to manipulate that brain neurotransmitter concentration by using pharmacological nutritional interventions. Quite some possibilities. What we have mainly done in our lab is that we use the reuptake inhibitors, meaning those drugs that you, well, quite some of them are antidepressants, by the way. So, but the drugs that block the reuptake of our neurotransmitters, meaning there's more neurotransmitters available in the synaptic cleft to exert their function. And what we see here, well, okay, no, first this one. This one changes position sometimes. So this is the protocol that we have used in the lab for our study. So we manipulated subjects, well-trained subjects, and we did, first we had a rest situation for 15 minutes. Then our subjects had to cycle for 60 minutes at a fixed exercise intensity, which was around 55% of their maximal wattage. So meaning it's not too hard, but still it gives us a nice steady state condition to look at potential effects. And after that 1 hour, it also obviously works to get them a bit fatigued already. And then after that 1 hour, there's a 30-minute time trial. And in that time trial, well, the time trial is calculated that if they perform at 75% of their maximal wattage, they will finish in exactly 30 minutes. But they are free to change their power output, so if they would decrease it, the time trial would take longer than 30 minutes and vice versa. And then there was a recovery period. Okay, here we see, I intentionally made it quite small so you don't start reading it, because that's not really the point. What I actually want to show is that these are all studies that have been performed in the past, and that have been trying to, well, they have manipulated neurotransmitter systems, mainly dopamine, serotonin, and noradrenaline. And quite some of them did not see any differences in performance. There were some more subjective differences, but there were no real differences in performance, most of the studies. And then I'm making a small sidestep now because we're going to heat stress, which is very appropriate here in the conditions in Slovenia. We all know that exercise performance drops once we are working in the heat. And so there's a ton of studies on that, so indicating that if it gets warmer, you will perform less well. What is happening at those moments? Quite some things. Your core and skin temperature will go up higher than in normal ambient temperatures. Your heart rate will be higher because you want to get rid of all your heat through your sweating. You have an increased RPE, and the will or the drive to exercise diminishes. So, meaning when you're doing things in the heat, that drastically changes your performance level and your physiology. And to go further on that and that thermoregulation and the link to the brain neurotransmission, again, studies from quite a while ago, but what we see here is a rat study in which the rats were, the microdialysis probe was inserted. That's what we can see here in the rat's brain at the height of the hypothalamus, the preuptake anterior hypothalamus to be more exactly. And basically, what they did was they've done several studies in that region or in that way. This one is the tetrodotoxin, which is a pufferfish poison. And what it basically does is it blocks most of the neurotransmission. What did we measure? We measured the brain temperature, we measured core temperature, tail temperature, because that's how rats dissipate their heat. And what did we find? Looking at the rat's core temperature, and here is the injection of the TTX. So they are performing exercise, as we see, for 120 minutes. There's the TTX, so there's no differences in core temperature if we look at this part, but then after the injection, what we see is that there's a huge increase in the core temperature of the rats during that exercise. At the same time, their tail skin temperature, so what I just said, what the rats use to lose their heat, to dissipate their heat, drops enormously. So from this study and then a couple of other studies that we have done, it makes sense that to state that our brain is very much involved in our thermoregulation, and especially the heat loss is an important mechanism there, and obviously that our hypothalamus is very much involved as well. So what we know now, or what we knew, is that there are changes. There are changes in brain neurotransmission when we are doing exercise. We know that if we just perform exercise in normal ambient temperatures, and most of the studies that I showed in that table did not really affect performance. So we wanted to take it one step further. We want to put more stress on the body, and that's why we started combining it. So meaning we have the pharmacological manipulations on the one hand, and we have the heat stress on the other hand. So I already showed you the protocol that we use, so we did not change that protocol. One of the first studies we did was with a serotonergic reuptake inhibitor. It's citalopram. So it means it's citalopram, and what we see here is the outcome of our time trial. So the performance aspect of it, time trial time, and then here we have the different conditions. So we have the placebo and the citalopram condition in 18 degrees Celsius, and then the same in 30 degrees Celsius. So what we see is the difference caused by the temperature, which is kind of expected. What we did not find was an actual performance difference, although subjects were, I think, about 1 minute slower in the citalopram trial, but there were no significant differences at that time. Another one is the Isbipropium. I don't know if anybody knows Isbipropium, Cyban. It is an antidepressant, but during the studies with Isbipropium, they kind of found out that it's actually a very good help to stop smoking. So now it's more used as an aid to stop smoking as well. What we saw here is a different story. So no differences at all in the 18 degrees Celsius trials, but there were, the subjects were about 9% faster when they were on Isbipropium in the heat. So Isbipropium is a dual dopamine and noradrenaline reuptake inhibitor, so manipulating or increasing the level of dopamine and noradrenaline made that the subjects performed about 10% faster. And well, on a side note, Isbipropium was not on the WADA anti-doping list, so it's something that could be used. It is now on the monitoring list, so it's well, it's still not prohibited if you have the right reasons to take it, of course. Just as a side note, we have not done these studies looking at which drug would be the best to use in a performance context. So we are looking at fatigue, of course, and the mechanisms behind that. Okay, another interesting fact in that trial was the core temperature. So this is the evolution of the core temperature at the, well, we have the rest phase here, we have the fixed intensity exercise here, we have our time trial and the recovery period. What we see, no differences in the fixed intensity or throughout the fixed intensity exercise, and then once we start with the time trial, we see that the core temperature rises much higher in the Isbipropium trial compared to the placebo trial. I put some nice lines on that. So what we do see is that our subjects went to an average of 40 degrees Celsius in core temperature, which is quite high and which was also kind of the cutoff for our ethical committee to continue the exercises or the experiments. What was even more interesting in that trial is so I have told you that they are performing much better. I have told you that they are getting much warmer. But these are the ratings of perceived exertion, the thermal sensation. And what we see here is that there's absolutely no differences. So subjects did not feel that they were pushing much harder, they did not feel that they were getting much warmer. So after that we continued because, as I said, dopamine and noradrenaline, so we tried to go a bit more specific. We used methylphenidate, which is known as Ritalin, of course, which is more dopaminergic, although we can't exclude the noradrenergic part, obviously. What we saw here was exactly the same. So no differences in 18 degrees Celsius, but a large performance improvement in the heat. So there was a 16% improvement in performance. And again, same story for the core temperature, which again went much higher in the methylphenidate trial compared to the placebo trial. Next on our list was the Nordinergic reuptake inhibition. And what we see here is, so we used Edronax or reboxetine. And here we found the exact opposite, which was a bit to our surprise as well. So, but what we saw is that both in the normal temperature and in high ambient temperature, reboxetine decreased performance. And that obviously made us think about the reasons why that would happen. And one of the follow-up, well, this is just an overview of the different studies that we performed using the heat trials as well. But what I want to get to is this one. So we proceeded with that noradrenergic reuptake inhibition, and we combined forces with the research group of Jacques Duchateau of the French-speaking university in Brussels, who are experts on the neurophysiology, and more specifically, they use a lot of TMS measurements in their lab. So we combined our experiments the way we have performed them, and I explained to you, and we added TMS measurements before and after our trials. And the most, well, I'm not going to go into detail in all the findings, but most important one is that throughout those different studies we have observed that the level of voluntary activation significantly drops when we have given the Nordinergic reuptake inhibitor, so indicating that subjects just recruit less muscle. Okay, so there's less drive towards the muscle to contract. And that's one of the main findings that came out of those studies. So, to conclude the physical part, we see is, I think I've shown you that there's evidence for central fatigue, meaning that our brain is involved in the onset of fatigue, that brain neurotransmission is involved, and that we can manipulate that if we provide certain drugs, medication. The environment is important in that. Okay, so changing the environment might lead to a more pronounced appearance of fatigue. There's decreased input from the brain towards the muscle. And also an important aspect that we noticed throughout our studies is that the drive to continue is an important factor. So when subjects are feeling much, are pushing much harder, are getting much warmer, but they still want to keep on going. We in fact, that's an anecdote, we had one participant who at a certain moment went above 40 degrees Celsius as a core temperature, and we had to stop him from doing the time trial, but he just wouldn't listen, so he would just continue. I'm seeing black things before, and well, in the end he stopped. But we kind of had to ask Kevin to pull him off the bike. But so I mean, yeah, there might certainly be a problem. One of the examples is Tom Simpson. I don't know who knows Tom Simpson, a famous English cyclist who died at the Mont Ventoux. He still has a statue, like I think 3 kilometers from the top of the Mont Ventoux. So it was during the Tour de France. He died. He passed away because of actually overheating. So it was a very warm day, and he also took quite some things that he shouldn't have taken, and that's that was the end for him. So I mean, there's quite some. I always give the example, like people who want, for example, to stop smoking, take bupropion. I'm not looking at anyone. Take bupropion and then go on holiday to France, for example, and decide to go cycling. Be careful. All right. So. Takes me to my next part, which is mental fatigue. So how do we define mental fatigue? We define it as the change in psychobiological state that is caused by prolonged periods of demanding cognitive activity. How is it induced? Well, I hope we all know it and we all experienced it, so that I actually shouldn't explain it to you, but I think we all spent quite some hours before our computer screens. If you keep on doing that, in the end you will be mentally fatigued. Well, some will be mentally fatigued quite soon, others might take a bit longer, and there's going to be some habituation and so on, but I mean, working for a long time will get you mentally fatigued. And the example I always use, I don't know who has kids, but if you have kids and you go to an indoor playground, for example, if you've had that experience, it's so noisy over there, and there's shouting everywhere. All the kids are shouting, and yeah, there's this question, and you actually just want to have a beer, obviously. But the moment you step out of that indoor playground, and there's no more noise, that's just a magnificent feeling. And then later on that evening, if you put the kids to bed, you can be like, ah. So, mental fatigue. So different ways to get mentally fatigued. How can we look at that? Well, we can look at it from different angles, of course, and one of them is the subjective feeling of mental fatigue. So the feeling of tiredness, the drop in vigor, drop in alertness. Also behaviorally, we would look at it like an increase in your reaction time, so that's no good, and a drop in the accuracy. And then neurophysiologically, well, or physiologically, there's an increase in heart rate. The changes in the theta and alpha activity have been proposed as well, changes in the P3 amplitude, also P2 amplitude. So there's different ways to kind of state that someone is mentally fatigued. I do admit that it's still a difficult process to really say now you are mentally fatigued and now you are not mentally fatigued. So it's more like a continuum, basically. What we try to do is that we need at least a combination of factors to be able to say that we succeeded in mentally fatiguing our subjects. So why do we want to see, or why do we want to study mental fatigue? Well, because over the last decade, a bit more than a decade by now, it became clear that it also affects our physical performance capacity. Okay, so being mentally fatigued makes that you will be less able to perform certain physical performances or activities. And which was the start for that? Well, that was this study by Samuele Marcora, study published in 2009. And what he did, he mentally fatigued his subjects by doing a 90 minutes AXCPT task, so a computer task. We have to respond or not respond on a certain stimulus. And what he did afterwards, he had the subjects perform an exercise trial, a trial to exhaustion. So meaning the subjects had to ride the bike, I think it was at 70% of their maximum wattage, for as long as they could. So that was his physical performance measure. And what they showed, what we see here is the rating of perceived exertion, and what we see here is the mental fatigue condition in the red circle, and the control situation, which was a documentary, watching a documentary was the control condition. What we see here is that they performed significantly longer in the control condition compared to the mental fatigue condition. So shorter time to exhaustion was the main finding, together with a higher RPE, so the rating of perceived exertion, as we can see it here, was continuously higher in the exercise trial in the mental fatigue condition compared to the placebo condition. But besides that, there were no differences. So no metabolic, no cardiorespiratory changes or differences between the control condition and the mental fatigue condition. So the only real difference that was observed is the rating of perceived exertion. So yeah, one of the first things we did was we wrote this nice review paper on how mental fatigue can affect, how mental fatigue affects physical performance. And what we saw, what we observed is that, for example, when you look at the studies that use cycling as a tool, and this is obviously not updated until recently, so it's from a couple of years ago. What we see is that if the trial is long enough, it will be the case that we observe a drop in performance. For the shorter trials, like a 3-minute all-out exercise, 60 minutes, so a really sub-maximal trial, we did not there were no real differences. If you look at running trials, very clear, all drops in performance after being mentally fatigued, and also for the more single muscle tasks, so the MVC here, we saw that the performance dropped in the concept of a time to exhaustion. So also meaning not a 2-minute task, but a much longer task. On the contrary, if you look at the anaerobic work, then we see that there were no difference in performance. which kind of makes sense because the more psychological contribution is also less if you have an all-out exercise. If you have an submaximal exercise, let's say you're continuously considering your pace, you are considering changing that, you're working on your pacing, for example, in an all-out exercise, that's a different situation. We've also looked at more sport-specific psychomotor performances. Different sports that have been studied by now, and well, there's new studies coming out basically every day. But main conclusion is that most of these sports are in fact also affected by being mentally fatigued, so the performance level drops. Also, technical performance changes. So meaning that, well, there's been some nice studies showing that, for example, a 30-minute Stroop task, which is, well, quite less than the 90-minute task that I was talking about before, so only 30 minutes Stroop task led to less accurate passes, slower and less accurate shots on goal in the Loughborough soccer passing task and in shooting tasks. Also reduced passing accuracy. Well, so reaction time, well, what we saw here, this is a study from our lab. So we performed a 90-minute Stroop task. We've heard the Stroop task before. What we observed was that the reaction time got slower after that task. And also this one is an interesting one, which was in table tennis, where we also saw that the ball speed and the accuracy of the shots was decreased. Okay, also tactical performance, I'm not going to go into detail, but also tactical performance is affected by being mentally fatigued. And this is just the example of the study we did on the technical skills, so more the physiomotor response time in badminton players. So it was, we tried to have the task as specific as possible for badminton, but still in a lab setting. And when I, for example, said that there might be opportunities to put that more into practice, then I think this is one of those chances to really create, and that's basically for the entire research on mental fatigue at the moment. So there's this lack of ecological validity in how we induce our task or how we induce mental fatigue. Meaning we put our subjects in front of a computer and we have them do that task, which, okay, gets them mentally fatigued, but how well does that represent the real world? Okay, so that's something we are still working on, and that's basically one of the things that I've already learned here. There's other things that we can do to get our subjects to that level of mental fatigue. But okay, for now we are doing it this way in the lab setting. We use the FitLight system that Florian also showed us before. And I think I did have a film. I forgot that one. So this is our subject responding to the FitLight system, in which we organize it this way that if the lights in front of him turned red, yellow, then they had to put it out in front of them, but if it was blue, there was a response inhibition, then they did not have to respond to the light in front of them, but they had to turn around, and so that's what we see here, turn out the light behind them. Okay, what did we notice? Well, that there was a large increase in the reactions. I think it was a 7% difference in response time to the stimuli once the subjects were mentally fatigued. Okay, in terms of mechanisms, that's also not quite clear at the moment. So it's kind of, I see it as a rather new field, and there's quite some discussion and some ideas about what would be the exact reason why subjects why people get mentally fatigued. What is happening, and one of the nice suggestions at the moment in terms of that mechanism is this one. So we have our cognitive demand here on top, and we also know that, well, game performance, but endurance performance, tactical decision making, technical performance, they all drop. So what is in between? well, that's obviously the brain, and one of the regions that is the most implicated until now is the anterior cingulate cortex. And the hypothesis would state that the change in brain neurotransmission would induce that feeling of fatigue, of mental fatigue, and not only the feeling, but then also the outcome, of course. So a rise in adenosine and a drop in dopamine would lead to mental fatigue. That mental fatigue would increase your perception of effort, which reduces your performance level, or it makes that you have an impaired executive functioning, causing your technical, tactical performance to drop as well, and in the end causing the performance drop in general. Okay, so when I said that we are growing in this area, that also means that we get quite some new projects that we have started at the moment. We're looking at brain oxygenation, central drive. Those are two ongoing PhDs at the moment. And then Uroš already mentioned our project that we have together, in which we will also be looking at the link between physical mental fatigue and brain neurotransmission, and where we kind of want to add to the things that we have already done in the past. So we are really interested in the brain activation, brain activity during those exercises. So that's something we haven't done in our previous studies. We, of course, and this was also discussed yesterday or the day before, the difficulties, and it was actually a question, Klaus, you just asked to Florian as well. The difficulty for now is measuring the EEG signal during that exercise. So, but I'm counting on Uroš to solve all that. Okay, so that's the brain neurotransmission. And then one of the things I'm really keen to do as well is look at more the practical application. So you have the fundamental research on the one hand, the practical aspects on the other hand, where we really want to go into the field. We have this collaboration, for example, with his name is Jesus. Jesus is a Spanish guy and works at the University of Extremadura. And he is looking at how mental fatigue manifests itself during a padel tournament. Who knows padel? He knows it now. Okay, so it's a mix between tennis and squash, basically. Yeah, so don't worry about it for the rest. I mean, but there is a professional competition in that. It's like the ATP in tennis. You have the same in padel. And what he did, he followed those padel players throughout an entire week of tournament, looking at how the mental fatigue manifests or evolves throughout that week. So he's working on that. What he's also doing is looking, for example, at if you have training sessions, what is the impact of a coach giving you a lot of instructions? How does that impact your level of mental fatigue? Then a PhD that is about to start now, well, actually these two are about to start. Here we will be looking more in soccer specifically, inter-individual differences. That's one of the other things that we notice. And I think I already said it. Some subjects are really largely affected by our Stroop task, for example, while for others it's like, okay, it's no fun, but I can manage. So there's large inter-individual differences, and we will try to find out what causes those differences. And then I think Kevin will be talking about René's PhD, where we look at mental fatigue in industry, use of exoskeletons, and how they might help us getting less mentally fatigued, or provide or be a tool to not mentally fatigue that much. So we are also working together with Professor Bailey from Elon University in the US, and also a recent PhD that started is looking at more the physical and mental fatigue and sports injuries. Okay, so there's quite some new things coming up, where some of them are really fundamentally focused, like in what causes mental fatigue, while the others are more the practical application of the topic. another important question. Can we counter mental fatigue? So we wrote a review paper on that, and well, as you can see, there's been quite some studies already that have used certain, mainly nutritional, but also some others, tools. Here is the physiological ones. So we see caffeine, which kind of makes sense, I guess, but also creatine is an important, cocoa flavonols, and so on. Chicken essence as well. Please don't ask, I don't know. And there's quite some others. This one, for example, the caffeine, maltodextrin, Mautrins. I will be showing you a bit of that. This is a study we have done in our lab. So if you look at the effects it has on mental fatigue, the different manipulations, we see that on behavioral level, well, most of them do succeed in reducing the level of mental fatigue, also subjectively. And then what is a bit striking is that there's just very few data on the neurophysiological aspects of it. And I think that's one of the nice things also for this meeting, for example. Yeah, there's quite a lot of things to do in that area. Not important. Now, I even highlighted it, the chicken essence. It's a Chinese study, which is also a sponsored study. That's all I know about it. Okay, so also behavioral countermeasures, so music, napping, exercise, for example, is also, so when I say that mental fatigue causes a drop in performance, actually the physical aspect can also be used to counter mental fatigue. So if you're able to, after a long day of work, if you're able to just go for a very light aerobic run, that will alleviate that feeling of mental fatigue as well. Okay. So again, much on the behavioral level. So there's quite some possibilities to counter mental fatigue. The most important ones that we identified were caffeine, odors, so smell, music, and motivation. But there's an absolute need for more standardization because all the studies are built up in a different way using different tools. Some don't even indicate whether they succeeded in mentally fatiguing their subjects and so on. So there's quite some stuff to do in that area, and obviously also the inclusion of neurophysiological markers can help us identify the further mechanisms of mental fatigue. Okay, so I told you I would show you the caffeine, maltodextrin, Mautrins study. So this is that study. What did we do? So subjects performed a flanker task before the intervention. Well, no, not before the intervention, before the mentally fatiguing task. So there's a flanker task here, then there's the 90-minute Stroop task, and then there's again the flanker task. And what we did as an intervention is we provided them with a caffeine, maltodextrin, Mautrins. So they had to drink that, put it in their mouth, rinse it for, I think it was 20 seconds, and then spit it out. Okay, so we interrupted, well, we did not interrupt our task, but we just did not record those parts. So because it took about 30 seconds, because we also asked for their the feeling of mental fatigue, for example. So either it was caffeine, maltodextrin, Mautrins, or placebo Mautrins that we gave them. And this is what we observed. So this is their subjective feeling of mental fatigue throughout that throughout that Stroop task. What we observe is that the caffeine, maltodextrin, Mautrins produced significantly less mental fatigue compared to the placebo Mautrins. So they were getting much more fatigued in the placebo condition, which makes sense and which is what we expect, while it was a lot less in the caffeine condition. Looking at, don't start reading everything, not necessary. I will show, voila. Okay, so what I want to show here is that the accuracy in the caffeine Mautrins was maintained. So the accuracy in the Stroop performance, while in the placebo condition, towards the end of the Stroop task, we see a significant drop in the performance level. So the accuracy was maintained much better in the caffeine condition compared to the placebo condition. And also for our flanker task, so the task we did before and after, we see that subjects were able to maintain performance in the caffeine Maltodextrin Mautrins condition, while they were not in the placebo condition. Who knows this guy? It's world famous. So this is Victor Kampenaerts. Nobody knows him, I understand. But he's a Belgian cyclist, and he, last year or 2 years ago, attempted to break the world hour record cycling. So around the track, doing as much distance as possible within 1 hour. He succeeded, so he was successful. He did 55 point something kilometers. And this was his routine before he started. I can't name the brand, I think, but you've seen it. He read our paper. Wonderful. No, there's other papers, obviously. But it's a nice video to show, of course. Okay, then another way to counter mental fatigue is, well, it's not really countering, it's like there's quite some talk at the moment about the fact that the better trained you are, so that's one of those individual differences, the better trained you are, the less prone you will be to mental fatigue, to get mentally fatigued. So there's this study from the Australian group of Ben Rattray, in which they have shown that the professional cyclists are less affected by a mentally fatiguing task than recreational cyclists. That's what we see here. There's obviously, so what we see here is the power output they produce, the time throughout, and what we see is that for the professional cyclists, who obviously produce more power than our recreational cyclists, mental exertion and control condition just are in the same line, while in the less trained, so in the recreational population, we see that because of mental exertion, they can produce less power. Okay, so in terms of take-home messages, I think we can conclude that there's an important role for the brain, and I haven't gone into real detail on the mental fatigue side because, well, there's still quite some controversy, doubts about what will be the role of the brain exactly. But specifically brain transmission will be involved. That makes a lot of sense, I think, or I hope that's one of the take-home messages that you can have now. In the onset of both mental and physical fatigue. So mental fatigue reduces physical and cognitive performance capacity. There's a wide array of countermeasures that is being studied or has been studied at this time. But if there's one message that I would kind of like to give, it is the fact that a lot more research is necessary, and I think the fact that there's not that much on the neurophysiological side, for example, shows that. I think we have to really invest in that, and the project we're doing together with Uroš is a step in that direction. So we need more fundamental studies on the one hand. On the other hand, I also talked about the ecological validity. Also there, we have to evolve towards more practical situations in which we can really apply this research. There's really something with those things. And then obviously I had to, I was doubting whether I should take a normal picture or another one, but in the end I went with quite normal ones. Again, an advertisement for our project that we have together. So it's a Belgian and Slovenian research project, combined project that got accepted last year, and where we are now still recruiting one student for the Slovenian side. So, and where we will be looking at the links between physical and mental fatigue and brain neurotransmission. So, and then the EEG during exercise. So we're going to try to combine all those things and make a very nice project out of it. So if there's interest, certainly send Uroš. I think you have provided your email or something. They can send you an email. Huh? Voilà. So send Uroš an email if interested. And then, okay, only a few. Well, obviously this is not me doing all those things. It's an entire team, and this is just a part of that team. So I would also like to thank them, of course. And that's the end of my presentation.
Thank you, Bart. I open the floor for questions. Yes.
Thank you. That was a really interesting presentation. I noticed when we were reviewing the literature about physical fatigue, all of the participants were males.
Yes.
Do you have any rationale for thinking that there would be sex differences or age differences?
No, it was really, or it's mainly from a practical point of view, in which, well, most of those studies are also using blood hormone concentrations, looking at those and potential differences, and that's just less straightforward in a female population. So that's basically the only reason why, at least we have never done those studies in a female population. But you are correct. We have, in fact, now that I think about it, we have done one study. Well, we work together with Phil Watson, who is at Loughborough University, and in fact, after our studies, they have done a study in a female population, and the results were exactly the same as the ones that we observed. So we did do it in the end. That's well, the easiest one here is caffeine. In a sense that caffeine will indirectly increase your dopamine concentration, and in that way, well, make you perform better. But it's not going to help your thermoregulation. So in order to do that, you would basically need some cooling interventions. The only nutritional, if you call it nutritional, thing that you can do is, for example, using ice slurries. So I don't know if you know those things, but it's like crushed ice, basically, which you can then drink, and which has the potential to cool your inside. But it's mainly subjective rather than it really lowers your core temperature. Not at the moment. The main mechanism that I also see is the fact that getting mentally fatigued changes your brain neurochemistry and basically I would say I do see some how should I say? I think mainly dopamine would be involved for me. In that sense that, well, there's also the motivational aspect. There's so many things that contribute to that feeling of mental fatigue. It's so difficult to say at the moment what it would be exactly. One of the things we are doing is the PhD on the central drive, for example, where we look at movement-related cortical potentials. So the output from the brain, let's say, to the muscle. But I couldn't really tell you which exact mechanism it would be at the moment.
But do you know what studies on Nordinergic? Is it like physiological output that you have muscle getting more sour?
Yeah.
Do you have measures for that?
Yeah, but those, okay, I see that. So no, those don't change because of mental fatigue.
Right.
Yeah. So it has to come from the brain.
Spinal mechanisms or intrinsic mechanisms of the motor neurons?
Also there's been one study, I think it was Benjamin Pageux, a Canadian guy, and he also did not observe any differences on that level. So he used, I think it was TMS, I'm not 100% certain, and he did not observe any differences in the mental fatigue versus the placebo situation. Yeah. So I have a dry mouth. I don't know why. You too. It's from talking so much. No, that's a very good question. And for example, in the Mautrins study, there is other studies that have shown that using the Mautrins would not have caffeine taken up in your gastrointestinal system anyway. So meaning that it would not really appear there. So it would be more a direct connection from the mouth cavity towards so you have a lot of receptors in your mouth that goes directly to the brain. And in terms of the sleep, that's something so we have different questionnaires that we give our subjects before they start with their trials, just to try to have it as standardized as possible. But it's something. It's one other thing is that we for example do all our studies in before noon, just to again have them in a as good as possible condition and not in a already mentally fatigued condition because of the day that has already passed. So we try to do it as good as we can, let's say. But you're absolutely right. There's a lot of things that can cause certain changes in that. Yeah.
So how big was the N? I'm sure you recorded.
Our subjects, you mean? The sample size is around 15 usually, 15 subjects. 15, 1-5, yes.
In both groups?
No, it's a crossover design. Yeah. So they do both conditions. And the study on the inter-individual differences, because again, it is a rather small sample size, we are aware of that. The study or the PhD on the inter-individual differences, there we are aiming for 100 subjects. That's going to be quite the work, but still, I think it's necessary. No, we haven't done that yet. Well, the only thing is that so if you have the flanker task and then the Stroop task, so the task switching is something that we haven't really done. What we did do, because we have always used the Stroop task, but we have two things. We changed two things on the Stroop task, meaning one is the fact that we do a max Stroop task first. So we look at the performance level of our subjects on the Stroop task. So we start with an interstimulus time of, I think, 1100 milliseconds, and we drop 100 milliseconds until they just can't produce, I think, an 80% accuracy level. And that's then so the last block they completed is then the level that we will be using in the actual Stroop task. And then the second thing we did is that, so the Stroop task, well, everybody knows it, but if the color is, if the color is red, they don't have to respond to, let me see, to the color, but then they have to respond to the meaning of the word. So we added an additional layer of difficulty, let's say, just to have the task as cognitively exhausting as possible. Yeah. Well, we've stopped doing 90 minutes now. We're back at 60 at the moment, but because 90 is really long. Yeah. Yes. Yes. Yeah, absolutely, and it will also increase the ecological validity because throughout the day you're also doing different things, of course. Yeah, absolutely right. Thank you.
But what is ecological validity? So what tests would be safe watching the kids? What tests would you use that would be more ecologically valid? What's the idea?
Well, no, it's not. I'm not looking for a test. I'm looking for. I'm looking to induce mental fatigue.
Right, but how? Like,
yeah. If I knew that, I wouldn't. No, that you want something that represents real life situations. So
that's like sitting in front of a computer, working, things like that.
Yeah,
that are pretty close.
Yeah, well, those things. Yeah, sure. So those things we haven't done them yet, and also in literature, there's not that much that looks specifically at mental fatigue throughout a workday, for example. So those things. It's just much more difficult to standardize those things because I guess everybody drinks coffee. So if you're drinking coffee throughout the day, and that fits nicely with your question, if you have a colleague coming to you, you have a chat, that's also going to alleviate that feeling of mental fatigue, for example. So you're right.
Okay, so I think we can say thanks again.